The moon and the rotation of the earth create every day too high or low tides. When these changes in the sea level are appreciable, energy can be obtained. Tidal power is a zero carbon emission way of using this energy. Since tides are predictable, the energy incorporation in the electrical grid is easier. Tidal barrage is the most efficient and cost-effective way of using this energy.
Tidal barrages may be placed inside a tidal estuary. They are used to capture the energy from the incoming and outgoing tides. They are characterized by a tidal range of vertical height h and a horizontal basin area A. A tidal barrage should span the width of the estuary. This is used to restrict the flow of the tide to within the turbine apertures.
At low tide, the sluice gates are closed. Then as the tide increases, a potential head is created on the sea-facing side. The sluice gates are opened, allowing the water to flow through the apertures and the estuary to fill. At high tide, the sluice gates are closed. As the tide retreats, the sluice gates are opened again, allowing the water stored in the estuary to flow to the sea, driving the turbine. The potential energy is dependent on the tidal range, delta H, and the basin area A, shown in this equation.
A bulb turbine is placed inside each aperture. The turbine uses a control pitch propeller. The pitch is adjusted on the propeller depending on the direction of the flow, giving the turbine bidirectionality. Allowing a potential head to accumulate before opening the sluice gates generates an increased flow rate through the aperture compared to that of the nominal tidal flow rate. This drives the propeller shaft, rotating a magnet which induces an electrical current across the surrounding coil.
The only existing tidal barrage power plant in Europe is located on the Rance River in France, which was completed in 1966. It has a maximum production capability of 240 megawatts. However, typically operation produces around 96 megawatts. It provides power for 130,000 homes annually, but also had a huge environmental impact. The barrage caused many of the local species to disappear, severely affecting the ecology of the area. It took more than 10 years for the ecosystem to recover to its previous state. Much of the blame for this environmental damage is placed on the construction of the tidal barrage, which was built on-site within two cofferdam walls, significantly limiting the exchange between the sea and the river. If they can be constructed with less invasive construction techniques and careful consideration is made for the local species, tidal barrages can be much more environmentally friendly and be part of our future energy solution.